Hello, my name is Sebastián Ramirez Tarazona. Tutorial we will explain how to do EFM modulation throws. So to start, we upload and in the command window we open a window with the library browser. This library we can find the diagrams to work different operations and sources that we can't use in this. And to start our work, we need to create a new model. So we give new model, and we will open a new window. And where we can start work. So to start, we need an input signal. So in this case, we use a sine wave. Found this block diagram and the difference we need to find here in the library block. So we open, and in this we write the keywords on the different block diagram. When we finally found a block to the window, we can start. We need to double click. We can edit the characteristic sine wave. Here, open the parameters of the design. We need an amplitude to 1 frequency of 10 Hz. So we have to be 10. With a simple time, we use this value. So so to do that, we need a gain. In this case, the block of gain and drag. In this case, we need a gain of 50 Hz. So after that, we need to define a code. So open the library browser and look of the constants, and we give a double click. Edit many characteristics. In this case, with the double click window to edit the characteristic. Use the value of this constant we need to. So we click OK, and we do this because a signal carrier. So that reason we need this constant. We use a zoom. So we found in the library browser, we found the block of 2. We drag the block to the operation, and also we need an integrator because we are to calculation EFM model. So we are talking about radians. We need another block diagram of gain. So in this case, we need to put in this block diagram, in this case the gain block, we need to put 2. So go on the window, and we can modify the value of the block diagram. For the signal, we need a function, more specific, a cosine function. So we found the block diagram in the library browser, drag the block, and double click for edit, and it process. So we drag the arrow to connect each one. This trigonometric function will need an amplitude, this signal. So For that, we also use a block gate. It needs this value y for the amplitude to the function. Finally, to show this, a block diagram that simulates an oscilloscope. In this case, we use in this diagram you have it's a simulator of an oscilloscope. We give play to run all the process, and when finish the program, we should give double click here in the scope. So we'll open a window with a graph and signal. So double click, and it shows the finally signal. So there is a modulation. We input, and advantage of this is that any characteristics giving a double click in here and
Hello, good morning. Today I come to talk about how the control turn out OLED on an Arduino card through the Simulink application. The first thing we will do is look for the option on and add the new package and install the necessary ones to make to the connection. Total, you should install 3 packages and wait for all to load. The first package to controller the target, the second package to realize the connection in the MATLAB Arduino, and the third package to connect the Simulink and Arduino target. When finish installed the first package, we make the same for other package. This and this. After to installing the package, I enter in the option of Simulink in MATLAB. And create a new model. In the interface of Simulink, I search the option of Tools and select the Run on Target Hardware and select Prepare to Run. In this option, I configure the specific topics for the control of the Arduino target for Simulink. Okay, in this new window, I configure the options. For example, the device vendor Intel, and select the hardware board. In this case, it's a Arduino Uno. Please wait. Okay, in after to select the target, I select the configuration for the target. In this option, the Simulink to search the port of to connect the Arduino. The voltage is the default of the target. The option the values. Okay, this is correct. The next configuration is in the option solver. We define the time of to run the program. With this option, the program don't have to finish. And to select OK for save these configurations. After to open the library browser, for select the block to use for this program. So the first it's Simulink support package for Arduino. That this is the package to install it before. Okay, to select command, this is on the all option to work in with our Arduino and Simulink, and I select digital output. After select the block to generate the pulse for to control the LED. And realize the connection. Okay. The amplitude of the signal is 1. The period is 1 for the 4 each second to start the LED. Select the pins and